Our next senior to present is Jeremy Zay, and he will talk to you about coding a video game. Thank you.
All right, hello everybody. My name is Jeremy Zay, and my senior project was coding a video game. The intent of my project was to learn a computer programming language, and since as a kid, I was not allowed to actually play video games. As the true Waldorf child that I am, I decided to make one myself. So I chose this project because I've always been fascinated by coding, and to have the ability to create something just by writing lines of code was amazing to me. But I knew nothing about this topic at all. I just liked the idea of it. So the first thing I had to do was find myself a mentor. Now my mentor was Priya Muddappa, and she is a programmer who uses her programming skills to analyze data. And the first thing she helped me do was to choose a programming language. And the language I chose is called Python. Now Python is a popular programming language that's often used for learning due to its simple syntax. Here's an example. But it's also a very good and effective language. And the next thing I had to do was set up what's called an environment. Because when programming, when you're writing your lines of code, what I'm writing, the computer can't automatically understand what is being written, because it understands a different language. So I have to write it in something that will take my Python writing and translate it into a language that the computer can understand. And this was a really frustrating process and took me almost a month, and during this entire time I couldn't write any lines of code. But finally, after a month, I was able to run my first program, which is called Jeremy's First Game. And this game displays a blank screen with a line, an ellipse, and a rectangle, each with their own colors and dimensions. Now, I didn't write this program. This is a simple program that's used to teach Python. But I took this program and the basic knowledge that I learned from this program about rectangles and colors and screens, and I wanted to create something that was my own with it. Now, the first program that programmers usually write is Hello World, but I wanted to do something a little more fancy. So I created this game. It's called Hello. Displays hello. Each letter is made up of rectangles with their different colors. You can do things with this game. You can change the background color. You can also have the colors cycle through the word, kind of to make a moving experience. I thought this looked cool. But most importantly, with this program, I learned how to write what is called, quote unquote, good programming. Now, with good programming, so when writing programs, it's not good practice when you're writing a program, to just have random numbers just plugged in everywhere. What you want to use instead is variables that equal a number. Because if you want to change something about your program, without variables, you have to go into every single number and change that number. Now with variables, you only have to change one little number, which is what I'm doing up here, and then you can change all the numbers, and then the program will still work. All the letters still display, it still says hello, and everything works just how I want it to. Now, the next game that I wanted to write was inspired by my childhood of watching the show Looney Tunes. Now, in this show, there's this little bird called Tweety Bird, and he's always being chased around by this cat. And he has this iconic catchphrase, which is, I taught, putty cat. In this game, the cat has to hunt the bird, and once the cat catches the bird, then the game restarts and you play again. It's a two-player game, and they have to move through this little obstacle course. But what's interesting about this is that there's one line of code that displays this background image here. And upon removing this one line of code, there's a very interesting bug that can be created. So since the line of code has been removed, the way this game works is every single frame of the game, the bird, the cat, and the background are all drawn. But when the background is not drawn anymore, whenever the bird or the cat moves, nothing is drawn over top of them. So wherever they go, nothing is drawn over top of them. So they just create this line, this trail of hundreds of birds and cats. But the game still works just fine. It just looks really weird. With this bug, you can create some interesting art. So I created this piece of art. And now, after improving my programming skills with these simple programs, I wanted to create a more complex game. And then I decided to create Asteroids. So the original Asteroids game was released in 1979. Some of you may know it. It's a two-dimensional game with a spaceship flying around in space and asteroids coming in from all sides. And the spaceship has to avoid these asteroids and can also shoot them and split them into smaller asteroids. And you get points for destroying these asteroids. And before everyone had an Xbox or a PS4 to play their games on, back in the old days, games were played on arcade machines. And I was inspired to choose this game when I heard stories of my dad as a kid playing this game in arcades in a bowling alley. And it combines my interests of physics and math into programming. But up until now, with these simple programs that I've been writing, they weren't that complicated. And in order to write these more complex games, I needed to grasp a new concept of programming called object-oriented programming. Now, in order to explain to you what object-oriented programming is, I'm going to have to use an analogy. So, now let's imagine that we have ourselves a duck. And we want to make our duck do something, so we're going to write a program to make our duck swim. So we're going to make a swimming duck. But, now that's fine, but what if we want to make our duck quack, do something else, such as quack? We now have to rewrite our duck, recreate it into a quacking duck. So we have our swimming and quacking duck, but what if we want to do more things? It's very inefficient to be creating something new every single time you want to do something. So now with this new concept of programming, let's go back to our original duck. And now what we're going to do is inside of this duck, we're going to give it actions that it can perform. So let's say we want our duck again to swim. We're going to build an action to make our duck swim. Now we want our duck to quack. We have another action to make our duck quack. We can even change the attributes of this duck to make it bigger or to make it swim faster or slower. And the way that this is structured makes it much easier to add these actions that this object can perform and to change the attributes of this object. Now, back to my asteroid game, I had to create the world that the game was played in. So, I created space with circles flying across it, which would eventually, I imagined, one day become asteroids that my spaceship would have to evade. Now, next I had to add my spaceship to my game, which would be controlled by arrow keys and would move forward and then could orient to a different direction and move in that direction. You could also shoot these asteroids, these circles, split them into smaller circles. But this spaceship was not moving exactly how I imagined a real spaceship to move. It's gliding through space, but it also kind of jerks when it goes one way and then turns to another way. I wanted it to, if it goes one way and then turns around to go the opposite way, I wanted it to kind of have to slow down before it can accelerate in the opposite direction. And this wasn't doing it exactly how I wanted. So if you imagine you have a car which is trying to make a sharp turn in snow, it has to kind of drift and can't make these sharp direct turns, and like how a skier can't just change direction immediately when it wants to. Now, up till now, you may have thought that programming is just drawing pretty shapes on a screen. However, it does require some pretty advanced math in some cases. Now, when I'm trying to do a math problem, I'll just take the nearest thing that's next to me, in this case envelopes, and just write some equations on them. And here you can see me doing that. But in order to calculate the way that this spaceship moved, this was not such an easy problem. And it didn't work right away, as you can see. This is not what I imagined a spaceship would do. I worked on this formula for a month. And then one day, on my birthday, I was sitting in class with my math teacher, Mrs. Rice, and looking through, showing her this program I was writing, and I noticed a small bug. Now, if you remember on this envelope that I was writing on, here it says B equals direction minus orientation. The small bug that took me a month to fix was as simple as making B equal orientation minus direction. And with that change, I was finally able to make my spaceship move how I wanted. As you can see, it's gliding in one direction. When it turns, it has to decelerate to a stop before moving in the opposite direction. As you can see, I've also changed the asteroids to look like randomly generated polygons. But this game was not yet playable. It was not yet really that fun of a game. And I added a little destruction sequence when the spaceship gets hit so that it can explode. So I added a few things to make it more playable. I added a little rocket on the back of the spaceship so that when you accelerate, the little booster rocket will be shown. I added these automated spaceships which come in from the side and shoot bullets at my spaceship. It can also hit asteroids and shoot them. I added lives that my spaceship had, so that if you die, once you lose all the lives, you lose the game. I added points that that you get when you destroy asteroids and spaceships. And then I also added an updated destruction sequence, which you will see in a minute. But if I manage to die, which, as you can see, I have been practicing this game for a long time, debugging it, and playing this game for hours as I'm trying to make it better. So I did end up becoming pretty good at this game. Now you can see the spaceship explodes and the pieces spin out from itself. I know most of you won't understand anything, but I want to show you some of the code. So here you can this is where I incorporated this movement formula that I had, and you can see the orientation minus direction equals. And I also, going back to the first program I wrote, I didn't write this was Jeremy's first game that was displayed. This was only 40 lines of code, and for comparison, I'm going to scroll through my asteroid game, which was over 1,600 lines of code, so a lot more. But after spending 4 months of writing this game, I want to finally play it for you here live and enjoy this game that I spent so long writing. Another thing I added was a way to make for the game to increase difficulty as the game progresses, and then I added sounds, so the game will get harder, and also these automated spaceships will shoot targeted missiles at me, which will get more and more accurate as the game goes on to make it harder. And what you do is you click to play, and then you can turn yourself around, and then you can go in a different direction. Tomorrow, you will actually be able, so I also added sound to this game, and I want to make sure that you guys can hear the sound that I've added. Okay, let me just restart quickly. All right, and you can hear the iconic beeping in the background of the Asteroid game. That was in the original game. You can hear explosion sounds. I added these automated spaceships which will shoot targeted missiles because when I showed this game to my brother and he was playing it, he decided to just sit in the middle and never move. And I worked so hard on this movement formula, I wanted people to actually move and not, okay, well, there I died. But I wanted people to actually move, so I forced him to move by having these targeted missiles shooting at him. The ticks increase in speed the harder the game gets until this game is tweaked a little bit. It's much harder. The one that you will be able to play this game tomorrow at the display table yourself. There will be a display app, and it won't be as hard, as difficult as this. But okay. But I could not have done all of this by myself, and there are a few people that I need to thank. First of all, I would like to thank my mentor, Priya Mudapal. If she could stand up, I'd like to see her. She was essential in my learning program, especially when I had to pick up this language and choose which language and set it all up on my computer. I had no idea what I was doing. I couldn't do anything, and she helped me so much with this. And as she was teaching me, she also fed me delicious Indian food. Kept me motivated and want to keep learning with her. And I would bring her broken programs that I wrote, and then she would just look at them and then fix them, and I just thought this was magic. How could she do this? I would also like to thank my faculty advisor for this project, Mrs. Rice, and I'd like to thank her for also sitting there with me and letting me talk through my problems with her, and sometimes then I was able to solve bugs. I would like to thank Mr. Hout for teaching me the math and the physics that I used in this game that I wrote, and for his help with my presentation. I would like to thank my dad for the endless hours of heated discussion that we had at the dinner table, arguing about the program that I was making. And I would like to thank him for playing Asteroids as a kid in an arcade so that he could suggest it to me to write. I would like to thank my mom for all the support and advice she gave me over this process, and for listening to me and my dad arguing. I would like to thank my classmates who I gave, who I would show them the game, and they would give me a little advice on what to change or add. I would like to thank the senior project committee and the school for giving me this wonderful opportunity. And finally, I would like to thank you all, the audience, for listening to my presentation.
Thank you, Jeremy. At this time, we will accept questions. Jeremy will answer them. So, do we have any questions for Jeremy?
Any guesses how many hours the whole process took you?
Well, some days I would get really invested, and I would work for like 3 or 4 hours at a time a day. And I worked on this asteroid game for 4 months, starting at around Christmas time. But that doesn't take into account all the hours it took me to learn programming and get up to that point where I was able to write something that complex. So probably like some weeks I would spend like 15 hours per week, and then some weeks I would not work that much, maybe spend a few minutes. When I was motivated a lot. Mrs. Height?
I need to clarify something, because Mr. Height and I spent many hours in 79 and 80 playing Asteroids at the 7-Eleven. And I'm looking at what you created, and if I'm hearing this project right, you saw the game and what it did, And then you took this program you learned about, or this coding language you learned about, and you just created it on your own. So it has nothing to do with how Asteroids was created in 1979.
Correct. Another thing that I wanted to do with my Asteroid game is not watch any tutorials online, because there's a lot of, for many games have already been written in this language, and you can just go and search how to write whatever program you want, and I didn't do that. I didn't look at a single program, a single tutorial to make this game. I just played, I went to a website and played someone wrote the original game, and then I looked at that and said, okay, I have to do this. And then I would write that. And then I looked at the movement and saw that it couldn't like turn like how a regular car would. It would have to go in one direction and then reorient and then go in another direction. So you can't, if that makes sense. So you can only pretty much go forwards. There's only like a booster rocket to go forwards. And I noticed that and then had to write it myself.
So the game inspired you, and then you went and figured out how to make it.
Yeah.
Exactly.
Mm-hmm. Mr. Lehman?
Yeah, it's still all Greek to me, Jeremy. So you chose this. How many languages are there, and why did you choose this one?
Well, there's hundreds probably. There are so many languages. This language is well, my mentor actually found it for me because this is the language she uses. It has a more simple syntax. If you remember the code, it's based on indentation and not on brackets, so it's easier to read what you're writing. Because some programming languages, you have a lot of these brackets, and it's really confusing to read. Whereas mine, it's just you just have it indented a little bit. If you have an if statement. Okay, I don't want to bore you all. Do you have a question?
I don't want to get too much into the coding, but it's kind of interesting. When you said when you're writing the code, you're not writing what the computer is reading. You write the code and then you put it into something that translates it into something the computer can read?
Yes, I have an app that I downloaded. It's right here, and I have to I write it into this app, and then it will this app can will interpret it on the fly, translate it into a language that my computer can read, and then it translates it from Python into whatever language the computer knows as it's running in real time. Does that make sense?
Yes. Why couldn't you write it in a language the computer can read? Why do you need that extra step?
Because they're not meant for you to write things in. It's the computer. I don't know exactly how it works. I don't know what language this computer, my Mac, knows, but it would be much more difficult to do that because this language is, the way that it's structured is much easier to write programming than what the computer would know. And any other question? Mr. Weedman?
Thanks, Eric. It's a great project. That's really interesting. I also am someone who spent countless hours in the 80s playing Asteroids. I appreciate the work that you did there. I especially appreciate the literal back of the envelope calculations that you did. I'm just wondering if you consider this game to be complete now, or if you want to tweak it further, or if there's another thing you want to do next.
I definitely don't consider it complete. Like even now, if I go back to the program, looking at it, I can see things that I would want to change, such as these automated spaceships going across. They're kind of like slow, like tanks. They're kind of just going across, really boring. I would want them to be able to actually change direction, or be smaller or bigger, and be able to like change direction. But that would take a lot more programming in order to do that. But I was happy that I actually added this from the original game. The original game, they don't target you. But in my game, they will calculate where you are and send a bullet at you. And it will hit you. Mr. Strivik?
Yeah, not to get into like the nitty-gritty details, but how do you program that physics of like the drifting? Because I had no idea. Like,
Okay, well, the way I did this, there are many ways, but when I thought of this problem, I immediately thought, okay, I can use the law of cosines and the law of sines to do that. So that's why I have the triangle up there, and it's just based on trigonometry and how you're adding one direction of a triangle, and you're adding two sides of the triangle together to create the hypotenuse. So like if it goes one way, and then you add the force to go the opposite, the other way, then the actual spaceship will move in a diagonal.
kind of good.
What's your all-time high score?
Oh, it's like 27,000. But I could definitely get higher. Oh, not with this version. This version is supposed to make me die quickly. Because I didn't want to be playing for like 20 minutes in front of you.
Can you level up?
Not really.
Make it go faster?
Oh, well, no. Your spaceship doesn't do anything different as the game goes on. But everything else gets harder. So as the beeping, it goes beep, 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 and then it'll go beep, 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 beep. And then as that's happening, the spaceships will shoot more accurately, there will be more of them, and there will be more asteroids. Mr. Cannon?
How hard was it to get your initial collisions going in your Looney Tunes?
Oh, the initial collisions, it was really easy because I actually used a tutorial for some other game for that one, and then I didn't copy it exactly. I made my own Tweever Looney Tunes inspired game. And that they used the collision, they detect collisions of rectangles. And for a long time I had arguments with my dad because I wanted to make the asteroids rectangles because I knew how to detect collisions of rectangles, but he was like, no, you can't do that. And I insisted on just wanting to use rectangles. And then eventually I decided, yeah, we can use polygons or circles.
In other words, it was right.
Yeah.
I was wondering if maybe you could, charge a quarter per game to college.
Yeah, tomorrow if you want to play my game, there'll be a table and you can come and play it yourself. It won't be as difficult. And yeah, you may have to pay a quarter, like how it was in arcades.
Do you think you're going to build any other games with Python or do any other things with Python now that you know it?
I was thinking about that, and when I first decided to do this project, I actually wanted to make a chess engine so that I could play chess against it. But I was told that it would be too difficult. But now, after I've made this, I can see a way that maybe I could actually write that game.
I have one question. Jeremy, my image of computer programmers, and not to offend anyone, is that they work alone and usually, tucked away in some office or some room all by themselves. And it sounds like from your project, you were working collaboratively with your mentor, arguing with your dad, and having your classmates look at your program and tweaking it as you went along. Were you surprised to find that this whole process of writing a code was actually more of a collaborative process?
Yes, I was. I also had that stereotype in my mind of programmers being alone in their room at night, just writing code. But I had lots of discussions with my dad. I would go to him and try to work out a problem with him, and then I would show it to my classmates, and then they would play the game and tell me you should change this or that. So yeah, it was actually quite collaborative, and with my mentor as well. Yo, Tom.
Do you think if you use a different language, it would be less lines? Because you can use brackets instead of a different line or using? Is Python inherently longer than others? Because of that?
I'm not sure, but I don't know too much about other languages, but I think you may still have to go to another line. You just also have to put all these brackets. But it's the reason why Python is, it's based on indentation. So if you have an if statement and then you have the result of the if, so you have if this happens, then that happens. You'll have if, and then you'll have the indentation of the line below, and then that will be what happens. Any other questions?
Okay, we'll take one more question. Izzy?
Do you make the watermark just for this game? Or where did you get that?
Where is this
Your
watermark?
name? Like your name watermark?
Oh, yes. Oh, okay. Well, not really. I had to download I downloaded a font. I went through like all these different signature type fonts and then picked out my favorite and then had to download put the file in my game and then I wrote my name to mark it as mine. Yeah, Tom?
Where did you go to make a font? What happened to that?
Well, I didn't know how to make it in cursive, so I just...
Is there an app that you can download?
Yeah, I actually compiled it into an app, so it no longer needs this interpreter. So I can send it to people if they want it, but that's why I have this, so that I can send it to people. So if anyone wants it, just let me know. And if you have a Mac, you can play it.
Well, thank you, Jeremy.